Okay, we are officially recording class. All comments, questions, and everything else will be heard, including any comments by the praying mantis over there. Okay, first question on the bell ringer. We are looking for two expressions that could be used to find the distance between 2.5 and negative 1.2. Since it is a distance question like we did in lesson 1.5, there's always two expressions for distance, and they always have to contain two specific things. What are those things? We don't remember. We want to say it, but we're not saying it.
Absolute value.
Okay, we have to have absolute value bars. So one expression we'll do in the purple, the other expression we will do in the green color. Okay, so both of them have to have absolute value bars. What operation must be involved in distance? No. Okay, it has to be subtraction. So our distance is two subtraction problems. Now, we just have to have numbers. And the order of the numbers doesn't matter. That's what makes distance so unique. You can take the 2.5, you can put it in the front, or you can put it in the back. And then you have your other number, negative 1.5, and it would go in the other place. So we have two distance expressions. Yes, ma'am.
Could you also do it like 2.5 plus 1.5?
That is what you would end up once we start working the top expression. But when we do the starting point, we always want to start out with subtraction and absolute value. Okay? Okay, the next one, we want to simplify the expression. So we need to follow some order of operations. First step, Millie.
You're going to do 5 times 6.
We will do 5 times 6. So 3 plus 1/2, parenthesis 4, and 5 times 6 is? 30. Ontario, next step.
30 plus 4.
We will do the rest of the parentheses. Good. So we have 3 plus 1/2, and in parentheses now Ontario is?
34.
34. Very good. The next step in this, Lawson.
You divide 1 by 2.
Can you tell me what half of 34 is?
Half of 34.
Yeah. You know, you can do the 1 divided by 2 and then times it by 34 if you want to. I was wondering if you could tell me what half of 34 is. Because that's what the question is. $17. And our final answer is, Lucy? 20. That's correct. Okay, so you have these wonderful handy dandy calculators, don't you?
It works.
And the fabulous thing about these handy dandy calculators is we can put the entire expression in the calculator and it will follow order of operations and give you the answer. If you put it in correctly, so we're going to experiment with that. So pick your calculators up. And we are going to press 3 plus, now to put our fraction in, we're going to do 1 ABC 2, open parentheses. The open parentheses is above the 8. Okay, 4 plus 5 times 6, close parentheses, and press enter. And you get your answer. Colin is in love with the calculator. He thinks it's the greatest thing ever.
I could do that entire time.
Well, unfortunately for my class, you have to show all your work. And remember, we use 2 calculators in this class. Majority of our stuff has to be done with the basic calculator that does not do fractions and isn't done scientific. Okay? But you will use this calculator all next year.
So on on our test, do we use the regular calculator?
For this unit test, you'll use this one.
Like for
The next test, you'll use the regular one. 9 weeks, you'll use the regular one. Okay. We're going to do some calculator practice. This will kind of remind some of us how to use the calculator properly. Okay. Oh, let's see. How would I put in my calculator 2 3/5? I want to know exactly what to press in the calculator. Kirsten.
You'll put in
2. Ontario? What do I press after the 2?
ABC.
The ABC key. And then 3.
ABC.
Then the ABC.
5.
And then the 5. Your calculator should have a 2, backwards L, 3, backwards L, 5. That is the calculator language for 2 3/5.
Why isn't there a button for the space? Because whenever you calculate it and you get the answer, then it'll be like a U.
I don't know. It's just the way they set it up. I don't know why it does differently. How would we put 2.8 repeated and turn it into a fraction? Turn it into a fraction. Millie.
You're gonna do 2.8. You're gonna take off the 8 and go to the decimals off.
Okay, so we're going to press in 2.8 and keep repeating the 8s until the 2 and the decimal is off. Okay?
And then second, then the PRB button. And then
Second PRB, enter. And what is the mixed number for this, Jatalia? 2 and 8/9. Excellent. Always got to press the equal button. A little from yesterday. The square root of 72. How would we use this calculator to find the square root of 72? Ren. Second x squared, okay. Very good. Second x squared, type our number in, close parentheses and press equal. And what do we find about the square root of 72, Clara?
it's rational, not irrational.
It's irrational. Jay, why is it irrational? No, not because it's repeating. Colin?
It's a decimal.
Simply because it's a decimal. Any square root in the calculator comes out as a decimal, we're going to claim it to be irrational. Yesterday's stuff I had to do on Edge Elastic yesterday. Let's do one practice of that. I gave you an assortment of numbers and asked you if things were rational or irrational. And when we worked with fractions, you had to check the numerator and the denominator separately. On this one, what do we find about the numerator? It's rational. You put it in the calculator, you get 5. What do we find about the denominator, Jay? It's irrational because it came out as a decimal. If one part of the fraction is irrational, Colby,
It's irrational.
then the whole thing is irrational. Very good. Yes, ma'am.
So is another way you can kind of tell if it would be rational or irrational is like with the square root of like how 25 is the square root of that and it can be times itself to get that.
Correct.
And then the 8 doesn't have limit to that.
Correct. We'll talk more about the perfect squares and square roots tomorrow. Okay, Claire.
One, what is the square root? Like,
We'll talk about it more tomorrow.
it
We're going to
also-
dig into it a little bit more.
Were you trying to make us mess up with that one question asking about rational?
No, I was just making, I warned you that one question would be different.
I know,
Told
I
you to
read
read.
them. I read them all.
All right, let's see. In your calculator, let's put the square root of 140. The square root of 140. And these two little squiggle lines on the screen, those mean about, okay? Because we're going to be estimating. So I want to know the square root of 140. Tell me out to 4 numbers after the decimal. 4 numbers after the decimal. Lucy.
4 numbers, like the whole thing's numbers?
Yes.
11.8321.
8, 3, 2, 1. Okay. I want this rounded to the nearest tenth. The nearest tenth. Noelle.
11.8.
11.8 is the nearest tenth. Nearest whole number. Audrey. 12. Okay. 6.43, and we'll just assume it goes on forever. We are going to compare it to the square root of 40. I want to know, is the 6.43 greater or less than the square root of 40, and how you decide on this? Oh. Lawson.
It's greater.
Okay, why do you think it is greater? How did you determine that?
Look, the decimal for 40 is 6.32455532. And you laughing at, bro? Oh yeah. And then the 3 and then the 2 and the 4, and those are all left.
Good. So this is what we're going to be doing today in the lesson. We're going to be comparing and ordering and estimating irrational numbers. So basically, all of our work is going to have to be done in decimal form. We're going to turn everything into decimal so that we can compare things. Easy enough? All right. So in your books, we're going to go to page 100. Page 100 for compare and order real numbers. Lucy.
Can I move up there by plate? Because this air thing is like
Really cold?
really cold.
Yes. Chose the coldest seat in the room.
I didn't choose that. You put me there.
Okay. Page 100, 100. We are officially in the triple digits of our book. Ooh, we got a visitor. Thank you. Okie dokie. We're going to start with question number 4. We are going to approximate the square root of 39 to the nearest whole number. So first would be a good idea is to know if we're working with the scientific calculator, how would we do that? Ooh, lots of pins. All right, Jay.
You will put second x2.
Second x squared, okay.
Munir doesn't have
Then
his
you
book.
put
He left it in Cyber Foundation.
Hey, folks, your mom and dads can listen to this class. Okay, so, and I know that they know your voices better than I know your voices, and I know your voices really well. So if you're off task, your parents can listen to class, and yes, they're hearing this as well, and can know exactly how you behave in class. Okay, I don't mind math talk. I think it's good, but some of this ain't math talk. So if we don't have our book, it'd be a good idea to maybe write things down until you get your hands on your book again. would be my recommendation. All right, Jay, you had to be at second x squared. What do I do next in the scientific calculator?
Then you put it 39. Then you add the caption.
Close your parentheses.
Oh, yeah.
Okay.
Then you press enter.
Enter. Okay, and what did you get?
You want me to say all the numbers?
Just about 2 decimals out.
6.24.
6.24. And our question wants a whole number. So what would this round to?
6.
This would round to 6. Very good. Okay, number 5. We want to approximate the square root of 18 to the nearest 10th. And then we want to plot it on a number line. What'd you tell you? Okay, second x squared. 4.24, okay. And it would go to 4.2, very good. The thing about irrational numbers that makes them so difficult is you cannot specifically place them into the number line, okay? We have to round them. That's why they're irrational. They don't have a specific place on the number line. Okay, we're going to 6 and 7. We want to compare the 5.7145 to the square root of 29. Where do we need to do our work for this one? Well, yes, we're going to use the calculator, but on what needs the work? Ontario?
29.
Okay. The square root of 29 needs to be turned into its decimal. So second x squared. Type in our number. Lucy, what did you get? 5.3851. Now we can compare that to 5.7145. Kate?
5.7145 is greater.
Very good. So our statement, 5.7145 ... is greater than the square root of 29. Very good. Notice when I write my answer, I put it back in the original numbers, not my work numbers. Okay? All right, compare and order the following numbers on number 7. Which of those, just by looking at it, do we automatically know is the least amount? Okay, negative 5.6 repeated is automatically the first in our list because it's negative. We have 5.2. What will we do with the 3 and 9 tenths?
You know that's less than 5.2.
Well, what's its decimal? 3.9. Okay, and we do know it's less than 5.2 even without doing that. But we do have the square root of 21. We need to change that one. Rachel. 4.58. Okay, so which would be the next one in our list? Lucy.
4.58.
I don't think 4.58 is the next smallest. Kirsten? The 3 and 9 tenths would be next. Then we would put SJ? Okay, the square root of 21. Let's go back to its original number. And the largest in the list, Ontario?
5.2.
Is 5.2. Very good. All right, on page 101, I want you to do questions 9, 10, and 11. I'm going to give you about 4 minutes, maybe 5 minutes. I would 9, 10, and 11. And I would read number 11 carefully. I've tricked half of my students today. So we're going to pause for a little bit so y'all can talk. All right, we're back to recording. We're going to go over 9, 10, and 11. I want you guys to have time to get your homework knocked out. Okay, we are going to compare these two numbers. SJ, I would love for you to tell me the answer.
Negative 1.963 1/2 is the greatest. And the square root of 5 is 6.
Good. It is greater than the negative square root of 5. When you did the negative square root of 5, did anybody put the negative on the inside of the square root symbol? Okay, if you do that, your calculator will tell you have an error. Okay? You'll learn in high school what happens when negatives are on the inside of your square root symbols. It's called an imaginary number.
Invisible math?
No, not invisible math. It's literally an entire number system called imaginary. It's crazy. It's easy. It involves the negative 1. You'll be fine.
So pretty much you just say imaginary for your answer?
No, it'll be an I.
I was always
You just wait. It's coming to you. High school's great. Okay, number 10. I want to know which number comes first. And if I had this video to show your parents, you two shadow boxing in my room while we're going over this, your parents would be so disappointed. I'm not going to say names. I'll just wait for the parents to listen to class and message me as to like who in your third period class was shadow boxing and having to stop class to be corrected on that. It doesn't matter if they hear that or not. You're distracting and not doing your own work. Shame, shame, shame. Okay, which of those numbers is going to come first when listed from least to greatest? The negative 3 is the smallest. You are correct. Number 11. I am going to take a poll. You're going to raise your hands. You ready? Yep.
Everybody.
If you want to raise your hand in just a minute. All right. How many of you chose 9 as your answer?
Now, Riley just stressing.
How many chose 10 as your answer? Okay, let's explain to our one why 10, because I know when you do the square root of 90, you get about 9.4. Why would this round to 10? Lacey?
So, to round to the nearest 10th first, it would be 9.5. That rounds up to 10. Also, if you're going to hang a painting, you're going to want it to be as big as possible, to be able to fit.
Yeah, this number right here, that 9.4 represents the painting. You can't put a 9.5 foot painting on a 9 foot wall. It just doesn't work that way. It's like if you wear a size 7 shoe, you're not going to put your foot in a size 6 shoe. It's too small. You'd be hurting. Okay? All right. I don't want 12. We're going to do 16 and question 16. Which list has the numbers in order from least to greatest? Cameron. Don't have an answer for me? Oh, I thought you had 2 hands raised. I was impressed. You were so excited. Millie. B. Are you sure it's B? Or is my B wrong on the paper? Oh, my B is wrong on the screen. Oh. It's the one that should match that one, right? That's your B? Okay, yeah, that's your B. But it's...
Ours is that, but the 3.7 and the square root of 5 are swapped.
RB is B, but then it's 1/2 and the negative 9/4 are swapped.
Oh, so my whole screen is messed up. Wow, isn't that great? Okay, so, Millie, read me the correct order of the numbers.
I put from left to right, -4, -9/4, 1/2, the absolute,
Okay. And that's the B in your book. Wow, nobody pointed out that this was wrong today. Nobody's paying attention. It's been the same screens all day. 17, and I'm going to leave 17 up on the screen for a minute because there's some information about it that you'll need to help you answer 17 before we get to this stuff. All right, I'm pausing. All right, we are going to, okay, 17. We have the area of a square poster is 31 square inches. We want to find the length of one side of the poster. And I put on the screen for you guys to find that you needed to find the square root of a square's area in order to find its side length. So the square root of 31 is about how much, Ontario? 5.56. Okay. What would this round to the nearest whole inch? Audrey? 6. Clara, 1/10 of an inch. 5.6. Very good. Okay. So everything we've done today just involves decimals, comparing and ordering the decimals. You have a short assignment. It is going to be on Savis. Realize you access it through ClassLink. You have the remainder of class, which is a good 20 minutes to work on it. Okay? If you get it done, you're done. No homework.